Welcome and hello. This is a video tutorial on HEC ResSim, and in this lesson, I'm going to discuss simulations. All right, what we have on the screen here is our network reservoir. It's very simple. There's a reach, a reservoir, and then a downstream reach. What we're going to do now is switch our module to the simulation module. And what we see here is nothing in the display because we need to create a simulation and select an alternative first before we can actually see something in the display here. Real quick, when we selected the simulation, we have basically the same type of look and feel as the other modules we've already worked with, such as the menu items across the top, and then the navigation tool, the module selector, and then over on the right, we actually have a simulation control. This is called the simulation tree with a few date times that will be populated once we have our simulation created. And of course, the main display area is right here. So the simulation is meant to compute the model, basically all the inputs and generate results from those. So let's go ahead and get started, and then I'll fill in some more details as we go. Go ahead and click Simulation, New, and then this brings up a Simulation Editor dialog box. So I'm going to just call it Simulation 1. You can add a description if you want. And then below that are three date times. There's the start of the simulation, the end of the simulation, and then this look back period actually comes before the start of the simulation. So between the look back and the start is what's called the warm up period for the model. So let's go ahead and add some date times in here. I'm going to say the simulation starts on May 5th at noon, and then it's going to end at May 15th at noon. And then it's the look back period is going to start on May 1st, also at noon. So you got to make sure these are in the right order. First, and then second, and then third. And then down below, we'll select all the alternatives we want to associate with this simulation. So I've created one alternative. I'll show you that in just a little bit later. We'll just go ahead and click the checkbox there and then click OK. Before I do that, I just want to take a peek at the file structure. In this video 39 is the name of my project directory. And this video 39 directory or folder is the watershed folder. So when I create a watershed, this is what gets created. And then this DSS file is my inflow. So that's something else. So these are the files associated with the watershed. Here's the watershed file itself. And then this RSS file is a directory, technically still a file, but the directory is where the simulation directory that I'm about to create gets created. So let's go ahead back to ResSim, click OK. So we see that our reservoir network has appeared in the main display. Let's go back to the RSS directory, show more options, and then refresh. And then there is the directory associated with this simulation we just created with some files here. Now that the simulation is created, we have our date times that we just entered show up here for the selected simulation. And then the one alternative that is associated with this simulation shows up beneath it. Over to the right here is the simulation tree. And this alternative one, alt one, is selected because it's bold. We can select a different alternative if I had a different alternative by just going right click and then set as active. This one has the option to set as inactive because it's currently active though. So that's how you would switch between active alternatives. Also, the display here shows the active alternative, and we can run the simulation by clicking Compute Alt 1 or just right click on that particular alternative and then click Compute. So I'm not going to do that quite yet. I wanted to show you some of the model setup input values so we can kind of know what to expect when the simulation runs and we check the results. Okay, so let me just go back to that reservoir network tab, and then let me right click on junction CP1. This has an inflow. So if I check the alternatives and then I check the inflow at CP1 is going to be a time series, but it's just going to be a constant 5,000 CFS. So remember that number. It's constant 5,000 CFS. Now let's head back over to the reservoir and check that out. What we have here is one uncontrolled outlet, so it's just a spillway, and it's starting at 1450 is the invert, and then that goes up to 1500 with flows ranging from 0 to 8,000 CFS. So that once our system hits an equilibrium and the 5,000 CFS that's constant is entering the upstream reservoir pool, uh, then 5,000 CFS will eventually be released, and that's going to be between these two data points, which corresponds to an elevation in the pool between 1480 and 1490. Back at the alternative editor one more time, I wanted to show the look back conditions. The elevation of the reservoir is going to start at 1400, so it's going to take a while to fill up until 1450 when the invert is reached before the reservoir release actually begins. And then the initial spill, of course, is 0 because it's below the invert. Okay, I think we're about ready. Let me head back over to the simulation tab and we're ready to compute. So I go ahead and hit compute. Here's the box. It says compute was complete. I click close and now we are, let's go ahead and look at some data. This video is not about plots or results, but I just wanted to show you guys what happened here. And then we can talk more about plots and results later. I'm going to right click on this reach and then click plot, and we see a constant 5,000 CFS through the reach, so that's good. And then let's right click on the reservoir and then click plot. And this is interesting. What we have in the top diagram is the elevation, and I said it started at 1400. The first 4 days is the warm-up period, and then the next 10 days is the actual simulation. So what we have here is the reservoir is rising, but then slower and slower as it begins to spill, and also the geometry of the reservoir also a factor there. Below, we have the flow rate, and this is the release from the uncontrolled outlet, which is just a spillway. And you can tell that it takes about 24 hours for it to even get up to that 1450 elevation, and then it begins to spill. And then it's just after about 10 days, it's just reaching about the equilibrium point where the release equals the inflow, which is 5,000 CFS. So that's rather satisfying, to be honest, to do all this work to learn ResSim on my own, and then finally um, to help you guys understand it as well, and to finally run a simulation and get some results here. So that's really exciting. We'll be running a lot more simulations and looking at more results in later lessons, and definitely the exercises as well. One last thing I wanted to point out before the end of this video is that in the tools options dialog box, when we're running a simulation in the simulation module, there's two new tabs, and that is the simulation tab here with a few options you can check on or check off, as well as the ResSim compute tab. That's also new. And these are just some options and parameters associated with the execution of the compute. So it's a little too detailed for me to go into all of this in this video. This is just a introduction to the simulation in HEC ResSim.